So I've shown some ways to make a mouse in previous videos, and that used surfacing in FreeCAD, but not quite like how I'm going to show today. This is a new method. This reminds me a lot more of how I might do it in SolidWorks. This uses tools from the Surface Workbench in FreeCAD, and before I just was using exclusively surfaces that I'd made from the part workbench. So let's go through some of the strengths and weaknesses of doing it this way, and some of the tools that are used in the Surface Workbench on FreeCAD. So first I'm going to create a reference surface for the top of the mouse and go through some sketching. And if you don't want to follow along with that, I'll probably put a timestamp in the description so you can just see the surfacing relevant part. But if you're following along and would like to make this from scratch, let's get started. I'm going to start by going to the Sketcher Workbench in a new part, and let's sketch on the right plane, the YZ plane. I'm going to make an arc. We'll make it center point coincident onto our vertical axis here. And maybe I'll make another one. So I got two arcs, and I've got my hotkey keyboard manager here in case you need to see what keys I use, but we're going to say T for tangent. We'll get these 2 points put together, and maybe I'll do a horizontal to our origin here. We'll go Shift R to make a radius, and I want this to be, how about 50.8? Maybe I'll do a radius over here at, say, 152.4 millimeters. I'll have my circle center point be vertical. In fact, let's add a horizontal constraint too, so it'll just be coincident onto our origin. And we'll give a vertical relation to the origin as well. 1 degree freedom left, so let's give that a horizontal. So we have sort of a mouse profile, fully defined sketch. From here, let's switch onto another sketch, and actually let's have nothing highlighted when we go onto the sketch. And we're going to say our YZ, or front plane. And the first thing I'll do is import the tangent point between my two arcs. And that'll be a good little connector here for another arc. Alright, so I'm going to choose my body of my arc. We'll give it a coincident relation. We'll give this a radius. How about 76.2? We'll add in a horizontal between my two endpoints, and maybe Shift H for a distance of 101.6 millimeters. And finally, I'll want to add a vertical relation to the origin to make sure that this arc is nice and center. So we'll say vertical there and close. Alright, now I just want to create my mouse surface, and for that I will use a part sweep type surface. We're going to choose our utility to sweep right over here. I'll sweep my sketch 001 to my select profiles. Selecting my sweep path, I'll hold Control and select my two arcs. We'll say done and OK. And there we have a nice mouse-like surface. And just like in the previous video, let's trim this surface out to get this to be what we want. There's a few methods that you could use to trim this out. What I'm going to do is only one way of doing it. My XY plane will be my top plane here. And I'm going to switch my view to wireframe so I can still see the outline of my surface, but I can see my full sketch. I'll create a arc, and I'll have my midplane be coincident, or my center point of my arc rather be coincident onto my vertical sketch axis. We'll make this have a horizontal relation with the H key between the two ends of the arc. We'll give this a radius, and let's assign that a radius of, say, how about 72? And I'll have a vertical relation relative to the axis with Shift V, or relative to the origin rather with Shift V. We're going to say 37 millimeters. Right, and then I just have to give this, say, maybe an edge-to-edge width for a full constraint, and I'll have that also be 72. I'm going to switch over to an end and rim point arc now. Let's go with a tangent, and we'll get these endpoints to be coincident. Shift R will give this a radius of 25 millimeters. And I've got 1 degree of freedom left. I'm going to leave that for now. Make another arc, and we'll make sure that these endpoints are both tangent and coincident. And now we'll give this a radius, perhaps 100 millimeters. And then we'll give this kind of a tighter 3-point arc. Again, tangent. And these are not connecting up. I've seen this before. In fact, I just uninstalled and reinstalled FreeCAD to do a quick test. So I know I've got that one issue that can be easily edited. So we're going to come over here to the sketcher, and we're going to say auto constraints. I'll just toggle that a few times and apply. And then we'll come over here to constraints and auto constraints there. Close and open my sketch, and that should get me so that these endpoints will actually snap together when we want them to snap together. Give that a quick try. Yep, they're snapping together again. So quick and easy fix there. If you're watching this video, you probably already know that trick on how to restore that. We'll give this a Shift R again and make this 10 millimeters in radius here. Maybe we'll go 70 millimeters down here. And we'll make sure that this center point is vertical with our origin. And that way we know that it ends on horizontal. I'll give this endpoint Shift V, negative 108 relative to the origin. And I think we've only got 1 degree left. And so I'll take this little second guy and give him a negative 82 relative to the origin. And we're fully constrained. Now, I can mirror things across this axis here, or I can just remake the sketch real quick. Now it's up to your personal preference whether you want to mirror or not. Usually my preferred method is to just hurry and remake the sketch real quick by adding constraints and relations. Alright, so we got that. If you mirror, you just have to re-add some relations that aren't copied over. And it's not bad, but sometimes it just gets a little bit more confusing. And you can have some good design intent by adding the constraints and relations the way that you would intend them to be. So we're almost done here. We're going to add equal, and we're done now. Alright, so we have a fully constrained sketch. I'm going to close this, and I think what I'll do, there's again several ways to do this, and I have done this in several ways, but with the sketch highlighted, I'll head over to the part workbench. Let's do an extrude. I have the create solid box checked. I'm going to say 200 millimeters symmetric. Okay, the point is I just want my solid completely intersecting my surface. I'll change my view back to as is, right? So I have my surface and my solid, and if I choose both, let's create, there we go, an intersection. And I just kind of trim my surface to be exactly how I want it to be, right? You can also do an extruded cut or some other kind of Boolean. So don't think that this is the only way to do it. So I said I was going to sketch out a lot. Let's go to the next sketch. I'm going to go to the XY plane. I'll revert back to the same view of wireframe. Now, let's have this center point be coincident onto this axis. Shift V. We're going to go with something like about 54 millimeters now. Shift R to give this a radius of, let's go with 100. And maybe I'll just give this endpoint a horizontal distance with Shift H of negative 30, right? And we're going to go with, I did not mean to make that coincident, so I'm getting rid of that constraint. We're going to go with tangent, Shift R to give a radius of 35. And now we should have 1 degree of freedom, which I will leave for now. And let's add another arc in here. Shift R, we're going to make sure that that's 40. T for tangent, make sure that these arcs are tangent. Let's do another 3-point arc now. Again, T for tangent. Shift R, do something a bit bigger, maybe 20 millimeters. We'll give that a vertical to the origin. And I didn't snap there, so we'll get those together. T for tangent. All right, looking good. Next, Shift V relative to the origin will be, say, -115. But it looks like I have an over constraint, so I need to auto remove. So getting rid of constraint 14, there we go. Now I should be able to Shift V, -115. Let's go with tangent here. Shift R, I'll make this 75. I want to make sure that I have a vertical constraint with the origin, so I know that that arc ends horizontal. And then maybe I'll choose this second one here. Shift V will go -65 millimeters, and that should be fully constrained. So I said I'd do a mirror this time in case anybody wants to see that. Let me adjust my workbench just a hair. I'm going to choose the elements. In fact, I could just box select everything I wish to mirror, and then lastly the axis I want to mirror about. Then I choose this mirror button here, and you'll notice it comes in but not at full constraint, right? So I'm going to choose the symmetric relation and choose specific points to be symmetric about my mirror axis. And that sometimes gets trickier than this, but I think in this case we stand a pretty good chance of. Now we still have a degree of freedom, right? And that's where it gets a little bit tricky. Where's our degree of freedom? So I think what I'll do, because everything that I'm going to click and drag is probably not going to work, I'm going to change this 100 to a 90, and you can see that these points come apart. So I'll delete this dimension altogether, and let's merge these points, right? And we still have a degree of freedom. So I can't change that dimension. But if I get rid of that, then we have a fully constrained sketch, but then it says that constraint 25 is too much. So mirroring just gets a bit more complicated. People always ask me how come I don't mirror, and that's why. Now we have a fully defined sketch, and I'll just simply do kind of what I would have done in the last time, and just add this in, make it tangent, fully constrained, right? So just different ways of doing the same thing. All right, from here, let's do an as is. And I notice that the corner of my mouse is drooping kind of low there. That might not look very realistic. So let's change our profile on our common just a bit. I'm going to go to my Extrude and edit sketch 002. Instead of 10, maybe we can make this real tight, like 2. If we close that, nope, that didn't help. 20, that gets a little bit narrow, so maybe I'll go 12. Let's try that. That's not bad. I'm just going to up it to 15 then. So we'll close that, right? We have a bit of a narrower mouse. It's looking not too bad. Go to my sketch 3, and maybe I can make this -110. And that might be a bit more of a realistic look. Okay. So that's the mouse. Let's begin surfacing now that we have a sketch and a surface to reference off of. And to do that, we're going to go to the Surface Workbench. I believe this just default comes with FreeCAD. And I might want to start out by making a little bit of a guide. So if I go to the Sketcher, We're going to go here. I'll choose my right plane or my YZ, and I'm going to, in the sketcher, let's import here and here. And then I can make an arc from these points. I'll go to my right view now and say Shift R, and we'll do something like 25 millimeters. All right, that gives me a little bit of curvature opportunity. So when we start sketching, we're going to go to the surface workbench, and I get these two kind of handy buttons over here. This one is what I want to focus on right now. It creates a surface from 2, 3, or 4 boundary edges. So if I click that, let's create a surface between the edges of my surface. Of course, you can see when I hover my mouse over my surface, only certain parts of the edge of the surface light up. And those are usually representative of either sketch elements or maybe places where I might have cut the surface to the right shape with other sketch elements. So the surface is broken up, its edge, into certain pieces that I can use for modeling. I'll click Add Edge over here and choose this first section, and then Add Edge down here. You can see we've created a surface between these two elements. Now, what if I want that to have a different curvature? Well, that's why I made my sketch. So I'll add another edge, and now the edge of the surface conforms to the curvature of the sketch that I used to specify. Now we can possibly add another edge. Let's see what it looks like. And you can see the view didn't update, so if I try to add that, it says curves are disjoint. So I'm going to remove my last edge and say OK. And there I've created my first surface. I can do the same thing to continue this onwards. Oh, I've got to click Add Edge first. But we'll go from here to here and probably to here, right? And that's how we can kind of negotiate around that curve there. And I can continue on down here. Now something interesting might happen over here if I add my edge from here and here, here. You can see how that works, but that's not quite how we see a mouse edge going. So I'll add another edge over here, and that works, but you can see at least the shading might indicate there's a little bit of roughness in that surface there. And so that might not be an ideal way to go. So there's ways that you can break up the surface into multiple parts. Let me give you an example. Let's say I want to do the back end of this mouse now. And I choose my surface tool, add edge, and I go from here to here. Well, what if I want it to end at the halfway mark instead of go all the way over? Well, there's a way to do that, because you can see that these unique sketch elements sort of divvy up the surface into unique parts. That way, when I go to highlight this edge, the yellow highlight comes in, and only certain parts of the edge are highlighted. And we can use that to our advantage. What I'll do is go back to my original surface, and it should be sketch 002 again. And notice I have this arc that's going all the way across. So one little trick is to make this for construction and simply add 2 arcs in its place, and that way you don't lose any of your existing dimensions or anything like that. So I'll choose the coincident and go from here to here. We're going to make everything coincident to that axis and then to this arc. And I accidentally added a coincident relation that I didn't mean to. So I'll just choose here to here, merge those. All right. We're going to go equal. There we go. All right, so I have a fully defined sketch, but now we have 2 arcs that make up that center point. So when I go to close this, Now this is divvied up in half because I made it with 2 arcs. So when I go to surface this, I'm going from here, add edge, to here. And we've created a surface. Now if these edges come in twisted, there's a few options. The easiest is to just flip orientation. The most complex but nicest is to add a little sketch like we did up here, which will straighten out a twisted surface as well. So what's another tool that we can use to help us finish up this mouse if we're getting kind of a rough surface if we try to fill in this face over here? Well, the other surface tool is pretty nice actually. Let's say I want to fill in the bottom of this mouse. It would get rather tedious to come in here and add edge, right? Because this only lets me select up to 4 edges. So if I try to select more than that, then no, won't work because tool requires 2, 3, or 4 edges. So I have to make a bunch of surfaces down there if I want to fill that in. That's not nice. So what I can do instead is this nice filled surface, right? And if I add an edge, the trick to doing this other tool is to add the edges in the order that they're connected to each other. So don't randomly choose edges, but go around the perimeter in sequentially selecting all of the next edges. And when you do, you get a nice surface fill. So unlike the other tool, this doesn't have a limitation on how many edges that you can select. And it's quite handy. But there's another little secret to this tool. What if for some reason I wanted a mouse that had a slight concavity to the bottom? Well, I can do that with this tool. What I'll do, I'll first delete this surface. Well, yeah, I'll delete it just so you can get better visibility on it. We'll go to the sketcher and I'm going to create a sketch to kind of outline the concavity. So right, I'll get on my YZ plane and I choose my start and end points of my profile. And I'm going to run an arc from one end to the other, and let's say I want it to be about that concave. I'll make that a 500 millimeter radius. So we'll close that. And now when I use this tool, I guess I'll fast forward so you don't have to sit through me selecting surfaces again. I've recreated my surface, but I can come out here to unbound edges and I can add an edge that, look at that, dictates the curvature of the bottom of my mouse. So that is a pretty remarkable feature that FreeCAD does. It really reminds me a lot of some of the cool stuff you can do in SolidWorks as well. So we'll close that. And now if you're astute, you may say, well, we had a rough time with creating a surface in this next part of the face. What if we used a filled surface instead? And let's take a look at what that might look like. I'll add an edge here, and then I'm going to keep on going around the mouse. And it does generate a very nicely smoothed surface. So if I say OK, well, now we have half of our mouse filled in, and we can simply mirror the surfaces from one side to another, and that really does begin to look like a computer mouse. I got to tell you, FreeCAD is really impressive in how able it is to do some of this stuff. But what if I want even more control, right? Well, we can do it. For instance, what if this surface didn't fill in? And I think a decent example of that might be if I delete this surface. And that gives me some reference errors, but that's okay because I can deal with those. I'll go to my sketch. Sketch 005 broke. So we'll just delete that. I've got a few things broken here. So I'm going to remake part of my sketch on my right plane due to some of the reference errors. And that's to be expected when you go messing with stuff. From here to here, Shift R, maybe I'll do a steep angle, right? Maybe 50. Close that. And we'll do the same on the right plane in the rear, just to repair some of these broken references real quick. We'll go from here to there. We'll go to the right view, Shift R, 50 again perhaps. Close that. So what if I do a filled surface from one end to the other? If you don't know how it's going to turn out, I believe I do. So let's give it a try. We're going to go from here, and I'll just fast forward this so you don't have to sit through me collecting all these edges monotonously. And it actually does work. You can see the surface comes in a little bit more rough. So that may not be a good recommendation. But my point is, even if that wouldn't have worked, which I have had mice where that didn't work, there's ways to get around it. And I want to show you one. And this will also help make the surface a bit smoother as well. So I'm going to create, in the sketcher, I'm going to select first 3 points. I'm going to select that point right there. I'll select this point right there and this point down here. So I've got these 3 points selected, and as you know, 3 points makes a plane. So I go to create a sketch, 3 points plane, and we notice we have a plane now that goes through all 3 points. Now I want to use my import tool, and I'll import 2 of the points that I've just created, there and there, and I can make a 3-point arc. Right, look how nice that is. So we're going to say Shift R to give that a radius. 30 millimeters is fine. Now I've got this little radius that dictates some curvature, and there's a few things I can do with that. I'll again fast forward so you don't have to sit through me monotonously clicking points, but we'll go to the surface and choose my filled surface here. Alright, so I've selected the exact same thing that I've done before, but now I can choose my unbound edge, add edge, and that can sometimes influence how that curve works, but of course it didn't work this time, and I can't expect a single example to work in every way that I want it to. But that's an example of one way that you can influence the curvature. This is the way that I'm more inclined to recommend. I choose a filled surface, I'll add edges, and this is usually, and I've discovered this in SolidWorks and FreeCAD, no matter what platform I use. If you have trouble surfacing, you usually want to break it down into smaller bits. So instead of using this as an unbound edge, let's use that as our boundary to our surface. And when I do that, okay, that also doesn't work. But the point in that is you can do multiple surfaces while using this as a boundary, and there's not really that much of a consequence to it. All right, so filling the entire surface can be a struggle, and doing it in parts may or may not work, and it may or may not solve the problem. In this case, it hasn't solved our problem. But if I head to the surface workbench and I create, a surface again where I add edge, and I just use this to help me sort of negotiate around this part of complex geometry. Right, so then I've created a surface that gets me around the corner without errors or any problems, and I could do the same thing as before. I'll add edge. Well, now I can have several options as before. I'll add an edge here. And if I fill this surface, oh, but I did not do it in sequential order. My mistake, so you can actually see what the error, oh, but it worked. Okay, that's a surprise to me, but I guess sometimes you don't have to do it in sequential order, but if you ever get errors or get errors downstream, focus on doing it in sequential order. So now if I fill this surface again, oops, with my filled surface tool, and I'll add an edge. I think it's best practice to select these in the correct sequence though, just in case. Look how much smoother that surface is. So I think hopefully this part is a good example of how you need to have both of these tools work together to really make some good surfaces, at least in some cases. Now these aren't the only tools on the surface workbench, because you have some up here too, which I will go into in another video, and there's some that are available in 0.19 that are pretty intensely awesome. So let's actually work on mirroring these surfaces, right? I'm going to choose all the surfaces that I want to mirror, and let's do that from the part workbench. I'll choose the mirror feature over here, and it looks like these are pre-selected. I just choose my YZ plane, and these mirrored nicely. Next, now you've seen how I can make the mouse have a concavity to the bottom of it. So this time I'll just choose a flat bottom mouse, which is a little bit more realistic to a mouse, and I'll create yet another surface. So I'll choose a filled surface as before, and I'll fast forward so you don't have to sit through me clicking these. And there we go. Now you'll see that I wasn't paying attention to what I was selecting there, but I was probably selecting a combination of sketches and surface edges. And I'd feel inclined to say that in FreeCAD, if you're doing a serious project, not just a quick here's how you do it video, right? In serious projects, choose sketch elements before anything else, and that usually results in the least errors. Next, so we have these surfaces, and I'm going to save the mouse right now. What do I do to make this solid? And for that you can install an external workbench known as the Curves workbench. And the Curves is an external workbench that you can install either through the add-on manager. So Tools, Add-on Manager, you can install it from there. Or in at least Linux, you can also use your terminal. So if we go to the Curves workbench, right, this is also concerned with NURBS surfacing and things. Here we have a solid that is pretty much watertight of surfaces, and when you have something that's quote unquote watertight, I can select all of the surfaces that form an enclosed volume, and then on the Curves workbench I see this green cube that says make parametric solid from selected faces. And when I click on that, I can hide all of my surfaces. Right, so now that I have this solid, and I can test it out to make sure that it's really a solid, I can do something like go to the part workbench, create a cylinder, right? And I have this cylinder that I can position in the mouse, and then I can choose my mouse and my cylinder and do a cut. And I created a hole because it is now solid. So I know that this is solid. I mean, how impressive is it that FreeCAD is able to do all this? I hope this video was helpful. If it was, please subscribe, and I'll see you in the next one.